Welcome to Chapter 7, Lesson 3, Part 1. This lesson has two parts. The second part of it will be dealing with how do you solve problems with kinetic and potential energy. This will be just the introduction to mechanical energy, which is basically kinetic and potential energy. Here we go. So, when work is done to an object, it requires energy. The energy it requires is known as mechanical energy. Mechanical energy is the energy possessed by an object due to its motion or its position. Potential energy and kinetic energy are both forms of mechanical energy. Alright, so you need to know that potential and kinetic energy are forms of mechanical energy. Notice the ball. As the ball rolls up and down this particular picture, it has kinetic and potential energy. At the top of these slopes, it has potential. Potential energy due to gravity because it's over the ground. As it starts to move forward, it gains kinetic energy. On section 5 here, once again, it has distance over the ground, which is the height, which is potential energy. And then it starts to roll forward again and gains kinetic energy, so on and so forth. Mechanical energy. Let's be specific. When you kick a football, you give mechanical energy to the football to make it move. When you throw a bowling ball, or when you roll a bowling ball, you give energy. When that ball hits the pins, some of that energy is transferred. We talked about this before in what we call a transfer momentum. It's basically a transfer of that kinetic energy to other items to make them move. The ball is moving with kinetic energy, and it's going to transfer some of that energy to the pins as you knock the pins down. Strike. States of energy. The most common energy conversion is the conversion between potential and kinetic energy. All forms of energy can be either of these two states, either potential or kinetic. Even the food we eat has chemical energy, which has the potential to give us the ability to move. Systems or objects with potential energy are able to exert forces or exchange energy as they change. Potential energy is the energy due to position. Alright, so let's look at this. In this particular example, the cart is over the ground. It's over the ground a certain height. That height gives it what we call gravitational potential energy. When you let the cart go and it rolls down the hill, that is converted to kinetic energy. Here is the formula for potential energy. EP is the energy of potential, or potential energy, where that's going to be in joules. Remember, work is also in joules. mgh. M is the mass of the object, G is gravity, and H is the height that it's raised. So we can figure out the potential energy of an object if you know how high it is over the surface, what the mass is of it, and if you're on the planet Earth, what the acceleration due to gravity is. I like to call this gravitational potential energy. Kinetic energy is the energy of motion, and potential energy is stored energy. Kinetic energy. The energy of motion is called kinetic energy. faster an object moves, the more energy it has. Okay, once again, the faster it moves, the more energy it has. Also, the greater the mass of that object, the more energy it has. Because kinetic energy depends on both mass and velocity. If you go twice as fast, your kinetic energy increases by 4 times. Here's the formula. This is why it increases by 4 times. Kinetic energy in joules is equal to half of the mass times the velocity squared. So the velocity is a bigger factor in the change of kinetic energy. Half the mass times the velocity squared. Here's another way you'll see this formula. Mass times velocity divided by 2. Which has a greater effect? Energy, mass, or velocity in y? And as I just said, velocity has the greater effect because velocity is squared. Okay, velocity is squared. So in this formula, the movement of the item has a greater effect on the kinetic energy. Potential energy is stored energy, stored chemical energy in fuel, the nucleus of an atom, and also in foods, or stored because of the work done on it. So you can do work by stretching a rubber band, by winding a watch, by pulling back a bow and arrow, by lifting a brick into the air. All of this, you are putting energy into a system. You are putting energy, and it is storing that as potential energy, giving it the potential to move. All right, this will be the end of Chapter 7, Lesson 3, Part 1.